integration of real integrals. Now here we can consider the evaluation of integrals of the form integral 0 to 2 pi f of cos theta sin theta d theta. Now in such a type of integrals, here we use the substitution z equal to e raised to I theta, and we know cos theta equal to e raised to I theta plus e raised to minus I theta divided by 2, and this is equal to 1 by 2 into z plus 1 by z, and also sin theta is equal to e raised to I theta minus e raised to minus I theta divided by 2, and this is equal to 1 by 2i into z minus 1 by z. Okay, now here f is a rational function of cos theta and sin theta. So that what is dz? Dz is equal to I into e raised to I theta d theta. So that d theta equal to dz divided by Iz. So we have our equation number 1 become integral over c f of z dz divided by Iz. Here z equal to e raised to I theta ranges counterclockwise once around the unit circle mod z is equal to 1. Okay. Now let us move to our first example now. Show that integral 0 to 2 pi d theta divided by root 2 minus cos theta is equal to 2 pi. Now this is of the form integral f of cos theta sin theta d theta. So here we can use the substitution z is equal to e raised to I theta, and here we have cos theta. What is cos theta? Cos theta is z plus 1 by z divided by 2. So half of, and d theta equal to dz divided by Iz. So these are the substitution here. We want to substitute in our given integral. Therefore integral 0 to 2 pi d theta divided by root 2 minus cos theta is equal to closed integral over c. Now d theta is dz divided by Iz, then root 2 minus half z plus 1 by z. Now this is same as 1 by I closed integral over c dz divided by then here we have minus z square minus 1 plus 2 root 2 z in the denominator. Okay, so let us rewrite as, then also here we have a 1 by 2 also in the denominator. Okay, so that is same as minus 2 divided by I integral over c dz divided by z square minus 2 root 2z plus 1. Let us arrange the terms like this. Now this is equal to minus 2 by I integral over c dz divided by, now we can solve this quadratic equation. So what are the roots here? Z is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is 2 root 2 plus or minus, here we have 8 minus 4, 4 root 4, 2 divided by 2. So this is equal to root 2 plus or minus, sorry, here we have 2 only, no root 2, here we have root 4, that is root 4 is 2. Okay, so here we have root 2 plus or minus 1. So this is z minus root 2 minus 1 and z minus root 2 plus 1. We can split the terms like this. Now it is clear that z is equal to root 2 plus 1 and root 2 minus 1 are simple poles. And here z equal to root 2 minus 1 lies inside C. This lies inside C and other one lies outside C. So here we want to calculate the residue of the given function at z is equal to root 2 minus 1. So our function is z minus root 2 minus 1 into z minus root 2 plus 1. So this is equal to 1 by z minus root 2 minus 1 at root 2 minus 1. So this is equal to minus 1 by 2. Therefore, integral from 0 to 2 pi d theta divided by root 2 minus cos theta equal to minus 2 by I, 2 pi I into the sum of residue at the sum of residues, because here we have only one singularity lies inside C and that is at root 2 minus 1. So we have to write the residue at the point root 2 minus 1. So into minus 1 by 2 only. So that is equal to 2 pi. Okay. Now let us move to another problem, similar type. Next question is evaluate integral 0 to 2 pi 1 by 2 plus cos theta d theta. Here also the function is cos theta. Now here we can use the following substitutions. Z is equal to e raised to I theta, cos theta equal to half z plus 1 by z, and d theta equal to dz divided by iz. And here the curve C is mod z is equal to 1. So integral 0 to 2 pi 1 by 2 plus cos theta d theta is same as integral over C 1 by 2 plus half z plus 1 by z. Then instead of theta we have dz by iz. Okay, now let us arrange the terms. 2 by I close integral over C 1 by z square plus 4z plus 1 dz. Now here we can find out the roots here. Root of the quadratic equation z equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So minus 4 plus or minus root 12, that is 2 root 3 divided by 2. So this is equal to minus 2 plus or minus root 3. So these are the values of z here. So this is equal to 2 by I closed integral over C dz divided by z minus 2 plus root 3 into z minus minus 2 minus root 3. Here we have z is equal to minus 2 plus root 3 and minus 2 minus root 3 are simple poles. And here we can see that z equal to minus 2 plus 3 lies inside C. So we can find the residue at that point. So residue at minus 2 plus root 3, our function is 1 by z minus minus 2 plus root 3 into z minus minus 2 minus root 3, and this is equal to 1 by z minus minus 2 minus root 3 at z is equal to minus 2 plus root 3. So that is equal to 1 by 2 root 3. Okay, so our required integral is integral from 0 to 2 pi 1 by 2 plus cos theta d theta equal to 2 by I, then 2 pi I into the residue. So the answer, this is by Cauchy's residue theorem. So the answer is 2 pi divided by root 3. Okay. Now let us consider the third question. This is a general question. Show that integral from 0 to 2 pi d theta divided by a plus b cos theta equal to 2 pi divided by square root of a square minus b square, where a greater than b greater than 0. Here we can use the following substitutions. Z is equal to e raised to I theta, cos theta equal to half z plus 1 by z, d theta equal to dz divided by iz. Therefore, integral from 0 to 2 pi d theta divided by a plus b cos theta equal to integral over c dz by iz whole divided by a plus b z plus 1 by z. Okay. So this is same as 2 by I integral over c dz divided by bz square plus 2az plus b. So this is equal to 2 by I integral over c f of z dz, where f of z is equal to bz square plus 2az plus 1 by here we can denote this by gz. Here we can simply take gz is equal to bz square plus 2az plus b. Now here, in order to find the singularities, we have to equate the denominator to 0. That means we have to equate g of z to 0. Thus we have bz square plus 2az plus b equal to 0. So that will give you z equal to minus a plus or minus square root of a square minus b square divided by b. So we have two values here. So you can take the first value as alpha minus a plus square root of a square minus b square by b, and the second value beta minus a minus square root of a square minus b square divided by b. Here it is given that a greater than b greater than 0. Hence, modulus of b is greater than 1. Modulus of beta is greater than 1. Okay. Also, alpha beta is equal to 1, or mod alpha into mod beta equal to 1. Here we have modulus of beta is greater than 1, and so modulus of alpha less than 1, and hence z equal to alpha equal to minus a plus square root of a square minus b square divided by b is the only singularity which lies within C. C is the unit circle. Now we can calculate the residue of the given function at z is equal to alpha. Okay, so the residue of the function f of z at z equal to alpha is limit z tends to alpha z minus alpha into f of z. So this is limit z tends to alpha z minus alpha into 1 by bz square plus 2az plus b, and this is equal to limit z tends to alpha z minus alpha into 1 by b into z minus alpha into z minus beta. So this is equal to 1 by b alpha minus beta. Now you can substitute for alpha and beta. So the answer is 1 by 2 into square root of a square minus b square. Now we can apply the Cauchy's residue theorem now by Cauchy's residue theorem. Integral over c f of z dz equal to 2 pi I into 1 by 2 into square root of a square minus b square. So this is equal to pi I divided by square root of a square minus b square. Therefore, integral from 0 to 2 pi d theta divided by a plus b cos theta equal to 2 by I into pi I divided by square root of a square minus b square. That is equal to 2 pi divided by square root of a square minus b square. This is our required answer. Okay. Thus we have integral from 0 to 2 pi d theta divided by a plus b cos theta equal to 2 pi divided by square root of a square minus b square, where a comma b greater than 0. Okay. Similarly, you can prove integral from 0 to 2 pi d theta divided by a plus b sin theta equal to 2 pi divided by square root of a square minus b square, where a greater than b greater than 0. Okay. Now let us move to the next question now. Evaluate integral from 0 to 2 pi sin square theta d theta divided by a plus b cos theta. Here we have to use the substitution z equal to e raised to I theta, 0 less than or equal to theta less than or equal to 2 pi, cos theta equal to 1 by 2 into z plus 1 by z, sin theta equal to 1 by 2i into z minus 1 by z, and d theta equal to dz divided by iz. So these are the substitution we used here. So integral 0 to 2 pi sin square theta divided by a plus b cos theta d theta is equal to integral over c 1 by 2i z minus 1 by z, that is our sin theta, the whole square, then dz by iz, then divided by a plus b by 2 z plus 1 by z. Now we can arrange the terms here. So this is equal to I by 2b integral over c z square minus 1 the whole square divided by z square into z square plus 2a by b z plus 1 into dz. Okay, now here we can consider z square plus 2a by b z plus 1 equal to 0. So this is a quadratic equation, so that will give us the roots minus a plus square root of a square minus b square by b, and z equal to minus a minus square root of a square minus b square divided by b. Now let us call this as p and this as q. Okay, so we have the poles are, z equal to 0, p and q, and here we have z equal to q lies outside c. Okay, so we can calculate the residues here. At first we can calculate the residue R1 at 0. Residue at z equal to 0 is given by z square minus 1 the whole square divided by z square into z square plus 2az by b plus, here we have that quantity is z square plus 2a divided by b into z, then plus 1. So we have z equal to 0 is a pole of order 2. So here we have this is equal to limit z tends to 0 d by dz of z square minus 1 the whole square divided by z square plus 2az by b plus 1, that is equal to limit z tends to 0 d by dz of z square minus 1 the whole square divided by z minus p into z minus q. So this is same as p plus q divided by p square q square. When substituting the values of p and q, we have this is equal to 2a divided by b. Here we have p into q is 1. Okay, p into q is equal to 1. So that is the residue at 0. Now we can calculate the residue at P also. We can denote that by R2. So the residue at P equal to, that is a simple pole, z minus P, z square minus 1 the whole square divided by z square into z minus P into z minus Q. So this is equal to P square minus 1 the whole square divided by P square into P minus Q. So this is equal to P minus 1 by P the whole square divided by P minus Q. So this is equal to P minus Q the whole square divided by P minus Q. So that is P minus Q. Here we have a P into Q is equal to 1. So what is 1 by P? 1 by P is Q. Okay. Now we can substitute for, now we can represent this P minus Q as square root of P plus Q the whole square minus 4 into PQ. So this is equal to square root of, already we have P plus Q. P plus Q is 4a square by b square and 4. So this is equal to 2 by b square root of a square minus b square. So this is the second residue. Therefore our required integral is integral from 0 to 2 pi sin square theta d theta divided by a plus b cos theta is equal to I divided by 2b 2 pi I into sum of residues R1 plus R2. So this is equal to I by 2b 2 pi I, then minus 2a by b plus 2 by b square root of a square minus b square. So that is equal to minus 2 pi divided by b square into minus a plus square root of a square minus b square, and this can be written as 2 pi divided by b square into a minus square root of a square minus b square. So this is the required answer. Okay. Now next question, evaluate integral from 0 to pi a divided by a square plus sin square theta d theta where a is positive. Here we can see that a by a square plus sin square theta, this is an even function. Okay, a divided by a square plus sin square theta is an even function. So I equal to integral from 0 to pi a by square root a by a square plus sin square theta d theta is equal to 1 by 2 integral 0 to 2 pi a by a square plus sin square theta d theta. So this is equal to a by 2 integral 0 to 2 pi d theta divided by a square plus sin square theta. Now here we can use the following substitution. Z is equal to e raised to I theta, sin theta equal to 1 by 2i into z minus 1 by z, and d theta equal to dz divided by iz. Therefore I equal to a by 2 integral over c dz by iz whole divided by a square plus 1 by minus 4 z square minus 1 the whole square divided by z square. Now this is same as a by 2I integral over c minus 4z square divided by minus 4a square z square plus z square minus 1 the whole square into dz by z. dz by z. Now here we can cancel one z also. So that is equal to 2ai integral over c z dz divided by z square plus 2az minus 1 into z square minus 2az minus 1. Now here C is the circle, mod z is equal to 1. So z square plus 2az minus 1 equal to 0 implies z equal to minus a plus square root of a square plus 1 and z equal to minus a minus square root of a square plus 1. Now we can denote this as P and this as Q. Okay, therefore z square plus 2az minus 1 equal to z minus p into z minus q. Similarly, we can consider the other function also. That means consider z square minus 2az minus 1. This is equal to z square plus p plus q into z minus plus pq. Now this is same as p plus q into this is same as z plus p into z plus q. Okay. Therefore, z equal to minus a minus square root of a square plus 1 equal to q that lies outside C. Also, minus q lies outside C. Therefore, I equal to 2ia 2 pi I into the sum of the residues. So this is equal to minus 4a pi into r1 plus r2. So here we have what is r1? r1 is equal to the residue at z is equal to p. Okay. So this is equal to z by z minus p into z minus q into z plus p into z plus q. So that is equal to p divided by p minus q into 2 into p plus q. Now that is equal to 1 by 2 p square minus q square. Similarly, we can calculate a residue at minus p also. Residue at z is equal to minus p. This is at z by z minus p into z minus q z plus p into z plus q. So that is equal to limit z tends to minus p z divided by z minus, here we have residue at minus p, so z plus p into our function is z minus p into z minus q into z plus p into z plus q. So you can cancel the term z plus p. Okay. Now for the remaining terms, you can substitute z as equal to minus p. So we have that is equal to 1 by 2 into p square minus q square. So our required answer is I is equal to minus 4a pi into sum of residues, that is 1 by p square minus q square. Okay, now you can substitute the value of 1 by p square minus q square. So that is equal to minus 4a pi divided by minus 2a 2 square root of a square plus 1. So that is equal to pi divided by square root of a square plus 1. So this is the required answer. Okay. Now we can move to one more example. Prove by contour integration, integral from 0 to 2 pi e raised to cos theta cos of n theta minus sin theta d theta equal to 2 pi divided by n factorial, where n is an integer. Here we take c equal to integral 0 to 2 pi e raised to cos theta cos n theta minus sin theta d theta, and s as integral 0 to 2 pi e raised to cos theta sin n theta minus sin theta d theta. Now we can consider c minus is. This is integral 0 to 2 pi e raised to cos theta cos n theta minus sin theta minus I sin n theta minus sin theta. D theta. So this is equal to integral 0 to 2 pi e raised to cos theta, then e raised to minus I into n theta minus sin theta d theta. Now this is equal to integral 0 to 2 pi e raised to cos theta plus I sin theta into e raised to minus in theta d theta. Now this is same as integral 0 to 2 pi. Here cos theta plus I sin theta, that is e raised to I theta, then into e raised to minus in theta d theta. After that we can use the following substitutions. Z is equal to e raised to I theta, c is the curve, mod z is equal to 1, d theta equal to dz by iz. Okay, thus we have c minus is equal to integral over c e raised to z raised to minus n dz divided by iz. So that is equal to 1 by I integral over c e raised to z divided by z raised to n plus 1 dz. So this is equal to 1 by I 2 pi I into the residue of the function f of z at z is equal to 0. Okay, so what is our function here? Our function residue of f of z at z equal to 0 is given by residue of our function is e raised to z by z raised to n plus 1 at z equal to 0. And here we can see that what is the order of this set is equal to 0. Is it a pole? For that you can consider the expansion of e raised to z divided by e raised to z divided by z raised to n plus 1. Now we know this is 1 plus z by 1 factorial plus z square by 2 factorial plus etc. Now you can take this 1 by z raised to n plus 1 inside the bracket. Then you can see that z equal to 0 is a pole of order n plus 1. Okay. So here we can use the formula for pole of order m plus 1. So 1 by m minus 1 factorial, that means n factorial, then limit z tends to 0, d raised to n by dz raised to n, then our function z raised to m plus 1, then e raised to z by z raised to n plus 1, that is cancelled. So that is equal to 1 by n factorial, then derivative is e raised to z itself. As z tends to 0, that value become e raised to 0, that is 1. So the answer is 1 by n factorial. Okay, so you can substitute the value of residue here. So the required answer is, here this I and I cancel, so 2 pi into 1 by n factorial. Okay, so that is our required answer, 2 pi into 1 by n factorial. So the answer is equal to 2 pi divided by n factorial. Okay, therefore we can conclude, therefore integral from 0 to 2 pi e raised to cos theta sin n theta minus sin theta d theta is equal to c, that is the real part of c minus is. So that is equal to 2 pi divided by n factorial, where n is an integer. Now if the question is e raised to cos theta, our question is e raised to, here our question is integral 0 to 2 pi e raised to cos theta cos of n theta. Here our question is e raised to cos theta cos of n theta minus sin theta d theta. And actually that is the real part. So this is the answer. And instead of this, if the question is sin theta instead of this cos, then the answer will be the imaginary part. And here the imaginary part is 0. Okay. So this is our required answer. Okay. Now let us stop now. Thank you all.